We choose to go to the moon in this decade and do the other things, not because it is easy, but because it is hard. With those words, spoken in 1962, American President John F. Kennedy set a seemingly impossible deadline: to land a man on the moon and return him safely to the Earth within the next 8 years. The first human spaceflight had taken place only the year before. It was a lot like trying to run before you can crawl. However, that first landmark flight had been made not by an American, but by a Russian. The Soviet Union had also previously achieved the first successful satellite launch. If their Cold War enemies were on their feet already, for the sake of pride and dignity, America had to get to the moon first. Whatever the cost. I'm Kari Faye, and this is Great Disasters. The space race began in 1955, when the United States announced their intention to put a satellite into orbit around Earth, and 4 days later, the Soviet Union announced their intention to do the same thing. The Russians won that first lap when the Sputnik 1 was successfully launched on the 4th of October 1957. This caused a great deal of concern in America. In an open letter to the New York Herald Tribune, under the title "The Lessons of Defeat," economist Bernard Baruch wrote, "While we devote our industrial and technological power to producing new model automobiles and more gadgets, the Soviet Union is conquering space. It is Russia, not the United States, who has the imagination to hitch its wagon to the stars and the skill to reach for the moon and all but grasp it. America is worried. It should be." It was even more worried in December 1957, when the first American attempt to launch a satellite failed spectacularly. The Russians rubbed it in. Their delegate in the UN offered aid to the US under the Soviet program of technical assistance to backwards nations. In 1961, Russia strengthened their lead by putting the first man in space. Yuri Gagarin orbited the Earth and returned home a hero. Whilst America also put a man into space shortly afterwards, it was almost a year before the first American made it into orbit. Russia would also achieve the record of putting the first woman and first civilian into space in 1963, when Valentina Tereshkova flew on Vostok 6. They achieved the first mission with the crew wearing shirt sleeves aboard rather than a spacesuit the whole time in 1964, and the first spacewalk in 1965. It was in this atmosphere that NASA was formed, and in which plans to reach the moon were formulated. Russia had so much early success that the American space program was under a great deal of pressure to move quickly. The Gemini program allowed America to make a resurgence. They set records for human spaceflight endurance, demonstrated the ability to adjust their orbit, dock with other spacecraft, and work comfortably in space. With those successes behind them, NASA charged at full speed into the Apollo program, its ultimate aim being to fulfill Kennedy's promise and walk on the moon before the 60s were over. The first manned mission of the Apollo program was designed to test the Apollo Command Service Module, or CSM, in Earth orbit. Depending on the performance of the craft, the mission was intended to last up to 2 weeks, testing launch operations, ground tracking, control facilities, and the performance of the Apollo module combined with the Saturn rocket. The CSM was what they called a Block 1 design. When NASA started planning for the lunar mission, they were expecting to use a direct ascent tactic, That would mean taking one spacecraft directly from the Earth, landing it on the Moon, and coming back. However, it soon became clear that this wasn't technologically feasible. They changed to a lunar orbit rendezvous tactic. This meant that the spacecraft which took off from the Earth would orbit the Moon, and a separate module would detach and make the lunar landing. However, they didn't want this change of plans to delay the program, so the first Apollo missions would still fly Block 1 design, testing mission capability in low Earth orbit. They would move on to Block 2 later and incorporate anything they learned from those early missions into the design. This allowed them to get on with the program without waiting for the Block 2 designs to be finalized. 3 unmanned flights, designated AS-201, AS-202 and AS-203, had already flown, and this mission was officially designated AS-204. The command pilot was Lieutenant Colonel Virgil Gus Grissom. He had been one of the original astronauts on Project Mercury, the second American to fly in space, and the first to do so twice, with a background as a United States Air Force test pilot and a mechanical engineer. The senior pilot was Ed White. He too had been a test pilot before becoming an astronaut, and was trained as an aeronautical engineer. He had also already been into space, on the Gemini 4 mission, where he became the first American to make a spacewalk. The third member of the crew was pilot Roger B. Chaffee. He had been a naval officer and naval aviator, and was trained in aeronautical engineering. Unlike his 2 colleagues, he had not yet been into space, although he had served as Capcom, or Capsule Communicator, for the Gemini 3 and 4 missions. He had not originally been chosen for the mission, but replaced Don F. Isley after Isley dislocated his shoulder twice during weightlessness training and had to have surgery. All 3 men had wives and 2 children each. The crew had chosen to call the flight Apollo 1. In June 1966, they got approval to design a mission patch with that name. The name was publicly used in a newspaper article in August 1966, and when the CSM was delivered to the Kennedy Space Center, the contractor NAA, North American Aviation, labeled it as such. There had originally been plans to fly the first manned Apollo mission in conjunction with the final Gemini mission in November 1966, but it was realized that this wouldn't be possible. The Apollo module wouldn't be ready in time, especially not if it had to also be engineered to be compatible with the Gemini craft. Instead, they scheduled Apollo 1 to fly in February 1967. First, though, it would have to go through a number of tests to ensure that both craft and crew were prepared. On January the 27th, 1967, the crew climbed into the command module on the launch pad, ready for one of those tests. This was what they called a plugs-out test. The spacecraft would be provided with simulated internal power, whilst detached from all the various cables and umbilicals, to make sure that everything on board was functioning as it should. Because the launch vehicle was not fueled, it was considered to be a safe, routine test. In other respects, however, it would be a lot like the real thing. The crew were fully kitted out in their protective spacesuits, which were connected to the ship's oxygen and communication systems. Once the hatch was shut, the module was pressurized with pure oxygen, so they would be operating in the same atmosphere that would be used in space. They worked through all the operations that they would expect to use for liftoff. The spacecraft test conductor Skip Shalvin talked them through various functions that needed to be checked, and they counted down as if toward an actual launch. At the point of liftoff, ground crew would remove the umbilicals so that the spacecraft would be operating on its own, as it would in space, and communications would be by radio only, just as they would during the real flight. Of course, as it was a test, nobody expected it to go completely smoothly. That is, after all, why it needed testing. The countdown had to be suspended to sort out various issues along the way. First, this was to investigate the source of an odd smell coming into Grissom's suit, and then it had to be delayed again due to communication issues, which had been going on all day. The recorded audio from that day picked up some completely unconnected communications from a pilot speaking to air traffic control, and there were some issues with STC and other ground crew being able to hear all the pilots clearly. Those issues clearly caused some frustration. Grissom was heard to quip over the radio, "How are we going to get to the moon if we can't talk between 3 buildings?" White replied, "They can't hear a thing you're saying." Grissom responded, "Jesus Christ." He then repeated his original comment. Approximately 1 minute later, there was a short exclamation from one of the pilots. It's uncertain who exactly spoke at this time, or in the following transmissions, but it is believed to be either White or Grissom. He either said "hey" or "flames." After a moment there was another transmission. Again, it's not certain who spoke, but it's thought to be Chaffee. "Hey, we've got a fire in the cockpit." He seemed to be starting to say something else, but his transmission was cut off. There was one final transmission, possibly made by White or Chaffee. It sounds like he said, "We have a bad fire, we're burning up." His voice trailed off into a scream. There were no further communications from the crew. STC futilely asked, "Hey crew, can you egress at this time?" There was no response. On the television monitors, they saw flames spreading from the left side of the command module, engulfing the whole thing in just a few moments. Within 1 minute of the last transmission from inside the command module, ground crew were attempting to remove the hatches. It took them another 4 minutes to do so. Even through the dense smoke, it was immediately obvious that the astronauts inside could not be saved. The pad leader reported over his headset that he couldn't describe the situation. Knowing how many people were monitoring the communications channels, he presumably didn't want to say it outright, but he had to tell the STC something. In the race to set foot on the moon, 3 men had died on the Earth. Grissom was found out of his seat, lying on the floor. White was lying sideways, just below the hatch. Chaffee was still strapped into his seat. Because the fire had melted the nylon in the astronauts' suits and fused it to the cabin, it took an hour and a half to remove their bodies. That task was finally completed 7.5 hours after the fire. An investigation was quickly underway. Everyone involved wanted to know what had gone wrong, and whether the Apollo program could go on. The entire launch complex was impounded to ensure that none of the evidence would be disturbed. The command module was extensively photographed inside and out before experts entered to start assessing and inspecting it. On the 1st of February, the module was removed to the Kennedy Space Center, where it would be meticulously disassembled so that every piece could be examined and investigated by the review board. This review board was, as a point of some controversy, largely comprised of NASA employees. It did, however, also include 2 safety experts, one an Air Force officer and the other from the Bureau of Mines. Despite this, the review board leveled unprecedented criticism at both NASA and the contractors responsible for the command module. The report ran to over 3,000 pages, and said that there were many deficiencies in design and engineering, manufacture, and quality control. The command module contained many types and classes of combustible material in areas contiguous to possible ignition sources. The overall communications system was unsatisfactory. Emergency fire, rescue, and medical teams were not in attendance. The command module environmental control system design provides a pure oxygen atmosphere. This atmosphere presents severe fire hazards. Although the report acknowledged that the exact cause of the fire would most likely never be identified, it was most probably a fault in a conductor located underneath Grissom's seat. Electrical current arced from that conductor to another object and sparked the fire, which spread rapidly, fueled by the material in the cabin and the pure oxygen atmosphere. From the positions of their bodies, it was thought that the crew had followed their emergency procedures to the letter. Chaffee was still in his seat, because his role was to maintain communications until the hatch was opened. Although the men were burned, Grissom suffered third-degree burns on over 1/3 of his body, White on almost half his body, and Chaffee on almost a quarter. Post-mortem examinations found that they had been killed by smoke inhalation. The fire had quickly melted parts of their suits and the tubes that carried their oxygen, so they had been exposed directly to the heavy smoke. NASA Administrator James Webb didn't dispute the review board's findings. He said, "The board has found error, but it has also found the capability to overcome error. If any man in this room asks for whom the Apollo bell tolls, it tolls for him and me, as well as for Grissom, White, and Chaffee. It tolls for every astronaut test pilot who will lose his life in the space-simulated vacuum of a test chamber or the real vacuum of space. Either the country is going to take the risk and get on, as we did in Mercury and Gemini, or we will not have a manned space flight program." One of the most shocking things about the Apollo 1 tragedy is that the problems with the Apollo program were not unknown prior to the fire. They were simply disregarded. North American Aviation and their subcontractors were supposed to deliver the command module to NASA with no defects. They had, however, had major issues along the way. When they got the contract, they were already working on the Saturn rocket. They were basically understaffed to undertake both contracts at once. The design team was so short that they still hadn't got to a workable design after 2 years. NASA had instigated an investigation in 1965, which had some heavy criticism to hand out. Despite this, NAA had delivered the command module on schedule in August 1966. NASA engineers would discover nearly 20,000 failures, errors, or omissions in the module. Apollo program manager Joe Shea conceded that there were issues at a press conference in December 1966. "We hope to God there is no safety involved in the things that slip through." The crew themselves expressed their concerns to Shea about the amount of flammable material in the cabin. They posed for a special crew portrait, just for him. The three of them grouped around a model of the CSM, with their heads bowed and hands clasped in prayer. "It isn't that we don't trust you, Joe," it said, "but this time we've decided to go over your head." Because they were still discovering and correcting issues in the module, those changes had to be made to the simulator that the crew were using to train for the flight. But there were so many, happening so often, that it was hard to keep up. Grissom was so frustrated by this that he took a lemon from a tree by his house and hung it up on the simulator to express his opinion. He wasn't alone either. A quality control inspector at North American was fired for honestly stating that he thought the CSM was sloppy and unsafe, and NASA's director of launch operations called it a bucket of bolts. The day before the fire, a similar test had been conducted with the backup crew, Wally Schirra, Walt Cunningham, and Don Isley. Schirra had spoken to Grissom afterwards. "I don't know, Gus. There's nothing wrong with this ship that I can point to, but it just makes me uncomfortable. Something about it doesn't ring right. If you have any problem, even a communications problem, get out of the cabin until they've cleared it up." But Grissom knew the risks and accepted them. He had, after all, been a test pilot. A few weeks before the disaster, he had told reporters, "We're in a risky business, and we hope that if anything happens to us, it will not delay the program. The conquest of space is worth the risk of life." One factor that contributed to the disaster was, of course, the haste with which the program was proceeding. In 1963, when George Mueller became head of the Office of Manned Spaceflight at NASA, a study had rated the chances of reaching the moon within JFK's deadline at only about 1 in 10. It said that a lunar landing could not be attempted with acceptable risk any earlier than late 1971. Mueller was determined to prove this prediction wrong, and had instigated a significant change in NASA's procedures. Up to that point, every component of a spacecraft would be tested individually. It had to be proven to work on its own before it was assembled with the other parts. Mueller issued an all-up testing mandate. Equipment would be delivered to NASA in flight-ready condition, and the various components and systems would be tested together. His reasoning was that the project was so huge and the systems so interdependent that repetitive testing of isolated components would not be statistically meaningful. Wernher von Braun, the famous rocket scientist, branded the idea reckless. He would, however, later admit that, without all-up testing, the first manned lunar landing could not have taken place as early as 1969. The second factor was the choice of an all-oxygen atmosphere for the module. On Earth, the air we breathe is about 21% oxygen and 78% nitrogen. However, out in the endless vacuum of space, replicating that atmosphere was very difficult. The Soviets had figured out a method, but they needed to build the walls of their vehicles much thicker, and they needed complicated airlocks and extensive adjustment periods for their cosmonauts to be able to undertake spacewalks. NASA decided that the equipment needed for this technique quite literally outweighed the benefits. It would all add too much weight to the spacecraft. A pure oxygen atmosphere could sustain the astronauts at 1/3 the pressure of Earth. The shell of the craft could be lighter, and overall it was thought to be more efficient. The main drawback was the risk of fire, but it was thought that in space, without gravity, any fire would extinguish itself on its own combustion products. There were some who pointed out the risks that this atmosphere presented on the ground. In February 1966, a year before the disaster, an editor of Science Journal predicted with uncanny accuracy that the odds are that the first casualty in space will occur on the ground. In October 1966, Shea was advised by an official from General Electric, one of the Apollo program's other contractors, that the first fire in a spacecraft may well be fatal. The atmosphere was not the only thing that made fire a great risk. There was also a lot of flammable material on board. Nylon netting and Velcro strips were extensively used to keep things in order and stop them from floating about wildly once they were in zero gravity. Although it was known that these things were flammable, it wasn't until after the tragedy that it was realized just how flammable they were. In the pure oxygen atmosphere, they practically exploded in flames. One of Shea's assistants said, "It was unbelievable. The stuff burned like you wouldn't imagine." The third factor was the escape hatch. If the crew had been able to escape quickly, they may have been able to survive. However, they were unable to open the hatch themselves, and by the time ground crew could open it from the outside, they were too late. Earlier space modules had incorporated a hatch that could be opened explosively from inside. All the crew had to do was blow the hatch and get out. However, an earlier incident in the Mercury program had led NASA to reconsider that design, and Gus Grissom had been the astronaut involved. When Grissom splashed down into the ocean in Liberty Bell 7, the hatch had accidentally blown open, letting water in and putting Grissom at risk of drowning. Although he had escaped, the capsule had sunk. It wouldn't be recovered until 1999. Fearing that a hatch could open by accident in the same way whilst out in space, NASA had changed the design. The hatch on the Apollo command module had 3 separate components, which took at least 90 seconds to open. One of the last items on the test schedule for that fateful day was one that Grissom had himself requested. They were to conduct a simulated emergency to practice the escape procedure and see how quickly they could get out. In the course of the investigation, attention was turned to a second command module, which had been delivered just 2 weeks before the fire. CSM-017 had already passed quality control inspection and was intended to fly with the first Saturn V rocket. However, on closer inspection, they found it had dozens of short circuits just waiting to happen. The wiring was haphazard and simply not up to scratch. On seeing this for themselves, Joe Shea welled up in tears. General Samuel Phillips, overall Apollo program director, was stunned into silence. In total, 1,407 errors were found in CSM-017. It would never fly a manned mission. To go forward, a number of changes were made to the Apollo design. An outward opening gas-powered hatch, which could open in 7 seconds, replaced the cumbersome 3-part design. All the wiring connections were given a flame-proof coating, and metal shields were employed to prevent insulation from getting scuffed off. Wherever possible, meltable plastic was replaced with metal. Fabric surfaces and spacesuits were made from a non-flammable cloth similar to fiberglass. And, during ground tests, the atmosphere would be 60% oxygen and 40% nitrogen. Shearer, Cunningham and Isley, who had been the backup crew for Apollo 1, were able to inspect the production of the command module that would take them into space for themselves. These changes were vital to the survival and success of the Apollo program. Cunningham later said, "The death of Gus Grissom's crew at the Cape made it possible to land a man on the moon on schedule. Indeed, it may have saved America's space program, so we cannot consider their deaths to be in vain." Deke Slayton, director of flight crew operations for Apollo, and one of the first astronauts on the Mercury program, agreed that they might never have reached the moon if the Apollo 1 tragedy hadn't occurred. "We uncovered a whole barrel of snakes that would have given us problems later." And when Apollo 11 finally fulfilled their mission, Neil Armstrong and Buzz Aldrin left an Apollo 1 patch on the lunar surface. in memory of the sacrifice Grissom, White, and Chaffee had made to get them there. Great Disasters is written, researched, and produced by me, Kari Fay. Visit the website at www.greatdisasters.co.uk for more, including links to further reading and reference material. If you'd like more Great Disasters, you can support the show on Patreon and gain access to exclusive mini-episodes that aren't available anywhere else. Just go to patreon.com/greatdisasters. I'd like to say a special thank you to patron Skella Heron, who has done just that. You can also catch up with me on Facebook, Twitter, Instagram, YouTube, and Vero. Thanks for listening, and please do stay safe.